Hi there. So we have our osmolarity lab data and how to manipulate in Google Sheets as well as LoggerPro. So here in our first column, we have the NaCl solutions as well as each of the independent variables. Please note that 0% in this case is the control. We have 5 trials, so we're going to be able to calculate the standard deviation. We have the initial mass recorded prior to submerging our potatoes into the solution. And we have our final mass, that is after the 20 minutes or the delay from submerging the potatoes inside the solution. We have units, so grams is our units, and then we have an uncertainty, which is plus or minus, and it's going to be 0.01 grams. We determine this uncertainty based on the digital scale, so it's plus or minus the smallest unit. So the smallest unit that is measurable by that digital scale was 0.01. So we have that uncertainty. Here in the calculated change in mass is calculated by the final mass minus initial mass. And in this case, the uncertainty is added. So we had 0.01 grams for the initial and then for the final, which means that if we add the two, we have 0.02 grams. The next part is to actually calculate in Google Sheets. So we're going to use an equation so we can put equals. And again, it's final minus initial. And then if we hit enter, it'll calculate it for us. In order to autofill so that we don't have to actually type out every single one or copy and paste every single one, if you move to the bottom right here and you see this plus sign come out, you're going to double click that and that's going to autofill for you. The next thing that we're going to calculate is the percentage change in mass. The reason why we want to take the percentage change and not look at the absolute change is that we have to take into account that the initial masses were somewhat slightly different per potato. So we're going to calculate a percentage change in this case. So if we look back at our equation sheet, the percentage change in mass is the calculation of the mass final which minus the mass initial, which is the change in mass, divided by the initial mass multiplied by 100 in order to get a percentage. In this case, uncertainty is determined by the smallest change, so that we have to take into account that we're now converting into a percentage, so we're no longer looking at plus or minus 0.02 grams. So right now we have 0.02 grams from the difference, and the smallest change is actually 0.60 grams from our 0% solution of NaCl in trial 2 to have a conservative estimate. So we're going to generate a percentage as well. So 0.02 grams divided by 0.60 grams multiplied by 100 equals 3.33%. So when we put that into our table here, it's going to be 3.33%. And again, this was the smallest calculated change here from our second trial of 0%. And we took this uncertainty of 0.02 divided by 0.60 multiplied by 100. So creating another calculation formula here, we have equals. We can simply use the calculated change in mass divided by the initial mass multiplied by 100 will give us a percentage. Again, we want to autofill this equation that we have here. So what we're going to do is wait for that plus sign in the bottom right hand corner and double click, and it's going to autofill for us. Perfect. So now we're going to have the calculated percent average change in mass. So again, we're just going to carry over our percentage uncertainty, and what we're going to do is calculate the average. So the equation for this is equals average open bracket, and we're going to copy or highlight in this case the 5 trials, close bracket, and enter. Instead of autofilling this one this time is because we only want to calculate it for each of the independent variables. So I'm going to copy and paste this formula into the next first trial box, next trial box, next trial box. There you go. So now I've calculated the average for 5 of the trials for each of the independent variables. So we'll just double check each of these equations to make sure that we've appropriately calculated. The last calculation we're going to have is a standard deviation, which shows the spread of the data. So here we've calculated the percentage change in mass. So this is a change, is an average of the 5 trials. And then the uncertainty is going to be the same. The standard deviation is a measure of how spread out or the variation of the data for each independent variable. So what we're going to do is equals STDEV, open bracket, and we're going to highlight the percentage change for all 5 trials per independent variable in close bracket. We're going to copy and paste this right next to our percent change, our average percent change values. So what you might notice though is some of you will have more or less than 2 decimal places. An important point in biology is that we want to maintain our decimal places. So here is a function where we can decrease or increase the decimal places. So we don't want 3 decimal places. We want to respect our decimal places and maintain it at 2 decimal places. If you are in chemistry, you may, or physics, you will be taught something quite different and have the need to respect significant digits, but this is not the case for us here in biology. So next I'm going to create a little table. So I'm going to create a little table here because it's going to be easy for us to copy and paste this into LoggerPro. So I'm just going to transcribe some of this information. So 0, 2, 4, 6, 8, 10 are independent variables. Our calculated average change in mass. So I'm just 18.3. Make sure that you're pasting the actual one. So you want to use paste value only, or on your computer, this is a PC, so this is Control-Shift-V. So make sure that you paste special or it's going to change your values. So Control-C, Control-Shift-V, because I wanted to paste the actual value and not the formula that it may copy over. And I'm going to do the same for standard deviation. The standard deviation is going to be important later on in order to compute the error bars. So now that we have this, we're going to highlight this entire section and we're going to copy it. And then now we're going to go into LoggerPro and we've started a new sheet and paste it. So I'm just going to shift this over so that we can see all 3 columns. You'll see that they're not actually labeled right now. So I can double click for column options. So the name of this column is our, in this case, NaCl solution. So the short name is going to appear up here. So I just want to say like NaCl percent. And the unit in this case is percent. And then I just want to make sure also the decimal places are respected. So instead of in automatic precision, I'm going to use 2 precision. Done. So now it's going to update that column. I'm going to do that for Y now too. So Y is the calculated average percent change in mass. Options, decimal, not significant place figures, but decimal places 2. Done. And lastly, our standard deviation. Let's go options, 2 decimal places. Done. So what you have noticed is once we've copy and pasted this data, LoggerPro has actually helped you plot out these data points. I personally don't really like these open circles because they tend to be really hard to see. So what I do is go back into my data, into my Y. So point symbols, what I'd like to use is usually something solid. So just the filled circle in this case. If you want to change the color, you have some options there as well. So there we go. We have our individual points plotted. What's nice is I want to be able to see a little bit more of this first point. So now I have the percentage change. What I probably want to add to is for the major and minor lines. So maybe I want some extra grid lines in there so I can see it better. And maybe let's add some axes options and make all values major ticks. So major ticks means that it's going to give me some more names here. So done. So there you go. Now it's gone 2, 4, 6, 8, 10%. So I'm just going to drag this over so that it's a little bit easier to see the point. I'll do the same here for 10. Just easier to see the point there. What I'm also going to do now is to make sure that I have my error bars based on the standard deviation. So I'm going to double click my data again. And I'm going to go into options, and then there's error bar calculation. So you're going to check mark it. We're going to have a fixed value, and then we're going to use the column. We're going to use a column called standard deviation. Done. So now we have error bars top and bottom. You should know how to interpret your error bars at this point. But if not, there are some notes on that, and you can double check that. The next thing I want you to plot is to insert a trend line, or not insert. We're going to analyze. Then we're going to put in a trend line. Boom. And with this trend line, it automatically looks at, it provides you the percent change equals y equals mx plus b, and it's going to give you a correlation value. That correlation value is equivalent to an R value. And you'll learn a little bit more in your readings or through explanations in class what the correlation means. So the R value versus the R square value. You can do a few more manipulations with the graph, but this is the basics of everything that you need to know.